Dull normal, the more PC term for idiot. How many are out there? Careful. Careful. Mathematically, how many are out there? Right. What percentage of the population are dull normal, according to that classification of it? So now this is I don't expect you to know the answer right away. This is one of the things to kind of process through. What you don't want to do is enter. Let me back up. We used the programs to normal last time, and we defined forwards and backwards problems. A forwards problem and a backwards problem. Do you remember the difference between a forwards and a backwards problem?
When you want.
Say that again.
Forwards when you have Z scores and want the area.
Nice. And backwards, the backwards.
When you have the area or percent and want the Z score.
Perfect. So a forwards problem is when you have a Z score and you want the area. And a backwards problem is when you have the area and you want a Z score. So the question is, what kind of problem does this appear to be?
Backwards.
How come?
Because we have the percentages.
But we don't know. Oh, okay, time out. I see what you're saying, Marty. Right, IQ is technically a percent. Good, touche, my friend. Yes, good. But you see what it says, what percent of adults are dull normal? See, I like what you're saying, though. That's an unfortunate coincidence I didn't even think about. IQ is measured in percentage points, really. But forget that for a second. Just say it's an IQ score. So we have the scores and we want the percentage. So this is a forwards problem. Thank you, Cindy. I didn't consider that.
About 10%.
I can go for about 10%. Now, how do you know 10%?
Because what I did, I just kind of eyeballed it and
Okay, good.
and went from, like 100 is 0, so 90 would be about, negative 0.5 to about negative 1.5. 33% is from 0 to negative 1, so I just spitballed it.
Good. That's great. And you know what? Very often that works just fine. Very often. So what Pat's talking about, I'm going to pause the screen real quick and draw up a quick curve from last time. Pause this. And this is a curve we actually explored a little bit in class. If you have the bell, general bell, or the normal bell, you got 0 in the middle, and then you pop out standard deviations from that. You got a 1 out here, you got a 2 out here, down to a -1, down to a -2, and so forth, and so on. Beautiful. Now, if you apply this is called a standard normal curve. If you recalibrate the horizontal axis so that it matches whatever the context you're talking about is, which in this case is IQ, what number's in the middle again?
100.
That was 100. That's the average. Remember what the standard deviation was? 15. So every standard deviation out adds or subtracts 15. So this would be a 115. This is a 130. This would be 85, I think. Yep. And this would be 70. So what Pat said was, okay, dull normal. Got it. Dull normal is 80 to 90. 80 to 90. So you got this down to about this. Ish, right? So 80, here's 90. And here, actually I put it down here, and here's 80. You can look at it down here. So we need that. We need that little sliver of area right there. So we got a ballpark of 10. Good. Suppose I need more precision, which you always do for publications. I'm not saying that you do for, sometimes it's good enough to know that that's less than 25%, or that's around 50%. Now the reason Pat went with 10, he said he spitballed it, I love that. You know what area is here, all the way down.
50%.
That's half, right? If you draw a line in the middle of the curve at 0 or 100, and go all the way down, that's the 50th percentile. So you know that half of humans that are measured have IQs less than 100. So there's 50%. Clearly we're down a little bit here. The trickiness is knowing how much you're down. Now you do know, however, from yesterday, and from, actually, not just from yesterday, it's from weeks now, between -1 and 1 is about 2/3 of your data. So from here to here is about 1/3 of your data.
33%.
That's 33%, right? Now the trick is, this is obviously much less than 33, but it also has this little sliver that's out here, and you're not exactly sure how much that sliver is. Ballpark, 10%, that's fine for a ballpark. But what if you need more precision? It would be helpful to know what? Can we use the normal right now?
Yes.
Kind of, right? Kind of. But you can't just plug 80 and 90 into it. If you well, I shouldn't say that. You can totally plug 80 and 90 into it. It's going to give you a nonsensical answer. Because if you plug 80 and 90 in, it's expecting z-scores. So I shouldn't even have these written here, actually. I had the arrows going down. Let me write them down here. 90, 80. You need those values up there that stand for those. So, because if you put 80 and 90 in, you can totally do it, and I can predict the answer is going to be 0. Because it thinks when you type in 80 and 90, you mean 80 and 90 standard deviations. So what you're going to then be answering is, what's 80 times 15?
A lot.
A lot. An IQ of like 1,000 or something like that. What's the chance somebody has an IQ of 1,000? Well, they don't. That's a 1-year-old testing as a 10-year-old. I mean, that just doesn't happen. Well, I guess it could. But the idea is you have to get a conversion factor back to figure out. Now, what would that be? Back, you said it's about half. We get about a half. I like that. No, that's good. It's spitball. It's ballpark. What I want to do today is chit-chat about a way to comfortably and precisely measure what these guys are. Can you see where 90 lies with respect to 85 and 100? Where? Closer to 85. How much? Give me a ratio. A third of the way from 85, 2/3 of the way down from 100, yes? Does that make sense? So 2/3 down from 100, 1/3 up from 85. I want to focus on the 2/3 down from 100. How about 80? Where does 80 live?
1/3 standard deviation
From 85?
right.
So how about from 100?
One and a third.
Good, good. This is where it starts getting a little bit, it's just arithmetic, but this is where students start like, oh, I'm carrying the 1, and it just gets too hard to do mentally. So it would be nice to have a conversion factor back and forth that's foolproof and gets us where we need to be immediately. And that's where Michael Phelps and Mark Spitz come in. We'll take a pause on the IQ momentarily. Pause on the IQ momentarily. We'll come back to it, I promise. I promise. Let's